Hi, and welcome to episode 7 in our series about what I/O, digital product passports, and a little bit more in-depth tutorials. This tutorial, we will talk about microcontrollers and machine reading, machine writing of DPPs. And of course, we will explain also the concept of our Incendo device or devices, and also why we have developed Dolores. So let's first start with the microcontroller itself. So there's a lot of different brands out there. We're focusing mainly on Arduino, which is the little device that looks like this. So it's a small computer. Obviously, it has a lot of inputs, outputs, analog and digital. And basically, it's built to control things and read data from its environment. It's super cheap. And it's this device now, what I'm holding here is the Arduino R2 Wi-Fi device. And they are ranging from about $25 to $50. And there's also nanos, which you see on the right part of the screen. The nano is a little bit smaller, nicer to integrate when you have something which you're very clear on that will become a product or something like that. We prefer to run the Arduino R4 Wi-Fi today because it's very cheap, $25, $30, and quite powerful, and it works very well for the Incendo device. So this is basically the heart of the solution and what we base things on. So what is then Incendo? So Incendo in Latin means burn. And Incendo is basically a concept for where you want to do machine reading and machine writing of NFC tags. And where you're looking at having it in an industrial environment where you don't want to use the phone. Because obviously, just for everybody to understand and to know, the basic thing is to use your standard Google Android or iPhone. And with this one, you can read and write NFC tags for different. You can program the tags basically to become a product and connect them to a physical item. But with this device, it's more automated and you can control everything. It can, of course, it runs on Wi-Fi. You can also run it in a way where it's connected to the API, so it automatically get tokens and these kind of things. It's built in a way where you can mount it any way you like upside down on a machine, on a running band for production. You can also use these for using plastic straps, and you basically can put it anywhere in an industrial environment. It has 4 functionality buttons here. The whole reading and writing area is at the What.io logo, and there is also 2 LEDs and a small display where you can run certain functions, and you can run it either on USB power. Or you can run it on basically 9 to 12 volts here. So it's a very elegant, simple box. There is other designs we're working on, but this is Incendo 1, which is ready to go. So yeah, the whole purpose basically is you have these identifiers for DPP, which is needed to connect the physical product with its digital data. Obviously, QR codes, most people are very well aware of today. And you can also use these microcontrollers to read the QR codes. Printing them is not something you would do probably with a microcontroller, because that would be done with a label printer and in a combination with our back office system. So the QR codes is a visual code, and it's generated in our back office system. The NFC tags, however, the second one here, it's obviously one level much more advanced. It has a serial number. It also can store memory, so it has a memory on it, an EEPROM. and we store about 144 bytes of data on these. And there we have the ability to also do authentication, and with our token system, we can also add tokens and these kind of things on the tags. So it means that programming these to become unique identifier for product is a little bit more advanced, and either requires, as I mentioned, the What.io app on the phone, or it actually requires some kind of hardware microcontroller to do this. The other two is interesting developments. There is different small circuits that actually allow you to do much more advanced things. And with the NFC EEPROM, you can actually simulate the NFC tag. So if you have a look at where I have my pointing finger, this is a small EEPROM where you can dynamically simulate an NFC tag. And that's very interesting for when you do research, or you want to do other things. Like in this case, there's actually an additional little board that measures CO2, temperature, and humidity. And these can be stored on this NFC EEPROM and read by the as a DPP. So it means that it becomes a DPP with real life, real environmental data. So it's quite interesting to have that as a second level of dynamic DPPs. AI vision is definitely something microcontrollers can do. However, today most of our research is using ChatGPT and doing GPTs, and that will be a completely different episode that we will do regarding this. So when we talk about microcontrollers today, we are focusing mainly on NFC. However, we have one in the works, one hardware device. It will actually be connected to Dolores. So there will be one board that can read QR codes, and we will make a whole another episode about that. But basically, it works with the What.io API, and it can automatically quickly pick up a QR code, read it, and report that back to the system. But programming is more a delicate matter, and especially if you have a lot of products going out and you need to have it in a I can't make a mistake environment. You want to control everything from the software and basically disconnect human errors from the whole process. And basically also you don't need to touch any buttons. It will be automatic. This is where these devices are brilliant, because you can pre-program them to a certain product line or a certain product category and these type of things. And obviously there is cases where the machines need to be able to read, especially in production environment or industrial environment. You don't want a human to be part of the actual reading through the iPhone. So the whole writing of NFC, as I mentioned, is a little bit more complex than actually just printing a label on a or a QR code on a label printer. So let's say we have like 10,000 units, unique identified units in a line, production line. We can set these devices up for complete automated programming. Still, every single NFC tag can be made uniquely, because what happens is that the Incendo device with its microcontroller actually speaks to the cloud, speaks to the back office of What.io, and automatically generates the token, saves the unique identifier, and everything will end up in the back office of What.io. So you are in full control, but you can build a fully integrated industrial environment. So yeah, so really using these as a base, the microcontrollers, it makes it very easy to make different type of iterations, as this is a standard component. And we will also, if needed, share the design if you want to build your own. All software development is done in C++, which is today a very standard language. You can also use ChatGPT to code whatever you want the Incendo device to do in C++. It's a very good companion when you develop. And there is, of course, other type of solutions with Microsoft, etc. In our case, we mainly use Arduino IDE for our developments, and the code we are doing for these devices and how it connects to what I/O is something we are happy to share on GitHub to enable. And also, actually, these all casing and everything, it's also something we share either on Etsy or any other printables and so on. So if you want to do exactly the same kit. So let's talk a little bit about the microcontrollers. Today we have been focusing on two microcontrollers, the Arduino Uno R2 Wi-Fi, which is very, very capable microcontroller. It is, however, a little bit more expensive than the R4 Wi-Fi and have a little bit less features, but it's super compatible. So it's backwards compatible to old code. And this sometimes, depending on what devices you want to connect up and sensors you want to connect, there is sometimes capabilities and compatibility issues. So we still work with the R2 Wi-Fi due to these kind of reasons. But we want to switch to the little bit less expensive Arduino R4 Wi-Fi, which is also faster and a better, newer design. And this will be the basics of most of our technology we will develop will be based on the R4 Wi-Fi microcontroller. We have different type of displays, but basically we use different TFT displays, small displays that can integrate on these products. Sometimes we just fit a small OLED because it's not. These displays are more for control and setting things up, and for a human to interact and see are things correct running. So this is another very interesting thing which is needed and part of the whole thing. This is the actual reader and writer of the NFC tags, and the white marking on the red circuit board is actually the antenna. So these wireless modules, they are used to read or program and write into the NFC tags. So these are part of our whole solution. And then, as mentioned before, there is also a very good NFC EEPROM solution, which is mainly done for research and simulations and testing. And also if you're building very, very advanced sensors that needs to take in, as mentioned, environmental data, these can be then hooked up like this on a test board and work as well in this environment. So there will be different Incendos, and Incendo is like, you get everything. Either you buy it from us as a complete system, which just works out of the box, or we can give you it as a maker kit so you can develop things on your own. And you can, of course, also design your own box if you don't think our system works for your environment. But also these will be added as 3D printed files. We still thought that we needed to do a little bit more. So we wanted to do basically, kind of a Tesseract style box where we have a standardized size of the PCB. And this box is called Dolores, and the whole idea is to enable you to do research with microcontrollers and this kind of programmable NFC tag system. So the Dolores is mainly like a explorer, a test bench for what you do, and we will issue a lot of different type of boards. And in this case, you see the Incendo board again. It's the same board as we have inside the Incendo device. It works more or less the same, but it has an ability to add other components on it and work a little bit more for research and these type of things. So it's a very nice way to explore and test before you actually build something that is working for your actual production environment. So this modular development platform, the idea is also to connect this to ChatGPT and also connect it with an amplifier for sound, microphones, and then you can also use the Google Cloud and basically start to analyze and see how can I use speech to text, text to speech to interact with the DPPs, and all this in this Explorer platform. So yeah, so we have a standardized size of PCB, so it's very easy. This is actually also part of the rigid structure of the box. So the box is completely 3D printed in Adnite, our 100% recycled material that we done together with Lost Boys Lab. And these boards are then in different versions for different functionality. And they all work in a way where they are shields. So if you look at the back, you see the shield here. Here is the actual microcontroller. So the microcontroller piggybacks on that. And in that little box, you can also have all the power supplies and these things. So we will continue to develop a different type of maker's kit. You can get them pre-built. We will also have the ability later on where you can get them finished as is, or you can basically get these directly from the store. So it a little bit depends on the case, and we are happy to develop custom solutions for you manufacturers for your actual production line, and these can then be built with a custom PCB, but with standard components. All these are standard components. We run Microsoft C++, and the API is the standard WhatIO API, and you run standard Wi-Fi protocols, etc., to get this technology into an environment where you very flexibly but very automated can program the NFC tag so it becomes like a regular part of any industrial product, and actually going beyond what you can do with a mobile phone, where you have still the human interaction that is needed to program the NFC tags. So that was kind of an introduction to Incendo, the hardware, and to Dolores, which is more the standardized different boards that we use to enable you to start to experiment and also test our API program and get some code and see how you can automate most of your DPP programming with our hardware tools, and of course our WhatIO cloud platform that is ready for working with these devices. So that was all I had for you today. Thank you very much. I hope you enjoyed it.